Hello! Today I'm going to be answering the question, what is terminal velocity? How do we understand this? Well, to start off with, we need to realise that the air all around us is made of tiny particles. Billions and billions and billions of tiny particles. When something moves through the air, it bumps into those tiny particles. And every time it bumps into one, it creates a tiny little force pushing back against the object. Now, all of the forces combined from bumping into all those billions and billions and billions of particles creates an overall force in the opposite direction to which something's moving, called air resistance, or drag. Now, the faster an object is moving through the air, the more air particles it's going to bump into, so the bigger the drag. The faster you move, the more air resistance. The faster you move, the bigger your drag. So what does that have to do with terminal velocity? Okay, well, let's imagine we drop an object from the top of a really tall building. First of all, the only force acting on it is its weight, pulling it downwards because of gravity. So if the only force is acting downwards, that means it's going to accelerate downwards. It's going to get faster in the downwards direction. Now, as it accelerates, as it speeds up, it's going to start bumping into those air particles. That's going to create a drag force in the upwards direction. That's going to make its acceleration a bit smaller. But it is still accelerating downwards, so it's going to continue falling and it's going to continue getting faster. If it's getting faster, it's bumping into even more air particles on the way down. That means the drag force pushing it back up is getting even bigger. That means the acceleration is getting even smaller, but it is still accelerating downwards, so it's still getting faster, so it's bumping into more air particles, so the drag force is getting even bigger. This continues to happen until eventually the drag force is the same size as the force of the object's weight, but in the opposite direction. That means that there's no resultant force acting on that object anymore, which means there's no acceleration. It's not going to be getting any faster, it's going to be continuing to fall at that same speed. It's terminal velocity. So that is what terminal velocity is. Now, there's two main things that can affect an object's terminal velocity. The first is its mass. The weight of an object is mass multiplied by gravitational field strength. So the bigger an object's mass, the bigger its weight. If it's got a bigger weight, that means it needs a bigger drag force in order for it to stop accelerating. So it's going to have a much higher terminal velocity because it's going to take longer for it to reach that size drag. The second thing that can affect an object's terminal velocity is its size. A bigger surface area means an object is going to bump into more air particles, which means it's going to have a bigger drag force acting against it. So the larger an object's surface area, the lower the terminal velocity. This is why parachutes work. When you pull a parachute, you're massively increasing your surface area, which lowers your terminal velocity, because you get a much bigger drag falling at the same speeds.